Hi, and welcome to Wood Innovation Square in downtown Prince George. When this park was created by the city in 2019, it was the first new downtown park in 25 years. It also serves as a courtyard for the Wood Innovation and Design Center, which, when opened in 2014, was the tallest wood building in North America, and the Wood Innovation Research Lab, which opened in 2018 and set new standards for energy efficiency. This lab is the home base for UNBC's research on wood engineering, but the story of the building reads like a research paper, with this structure being the experiment.
We did do a few things differently here. So one thing is, yes, we did not go with a steel structure like the ordinary approach would have been, and nothing bad about steel, that's good. What we wanted to prove was the concept that you can build large, rather industrial buildings in wood as well. Steel has a very high heat conductivity, so you have thermal bridges, and it becomes very difficult to build a steel building truly energy efficient. So wood has an advantage here, a natural advantage, and so we wanted to build a so-called passive house.
Passive houses are super energy efficient and require very little energy for heating or cooling. How? By keeping the surface area low, sealing everything to be airtight, and packing thick walls full of insulation.
The walls are about 50 centimeter thick, so that is, 18 inch, I think. The way we've done it was, well, a little bit innovative, at least in the sense that we used trusses, which are usually used for the ceiling, re-engineered them a little and put them upright as studs, if you will. So that gave us the option to have 50 centimeter of insulation in there.
What did that help to achieve? Well, it's the most airtight building in North America and one of the first industrial buildings in the world to be certified as a passive house. The results are a building that's comfortable when it's -40 or +30.
We have a footprint of 31 by 31 meter, or roughly speaking 100 by 100 feet. So that's significantly larger than any single family house, and it's a decent size. But we managed to have a heating bill which is actually lower than the average house in Prince George. Our heating bill in average is somewhere between $900 and $1,000 per year. In our particular case here, the architect, the engineer, the contractor, none of them had ever built a passive house before. None of them has ever built a building which were anywhere close to these airtightness levels. It's a perfect example because it shows even when you're not experienced, but if you have a common goal and you really want to go for it, sure, you can. I mean, that's the best proof.
Proof is exactly what this building is all about, from the structure itself to what goes on inside of it.
The testing we're doing is really from a small screw to all the way to large composite panels and everything in between. So different types of connections and CLT, as cross-laminated timber panels, dowel-laminated timber panels, any kind of solid wood panels, for example, or other engineered wood products. And then we test them on the strong floor and strong wall, and essentially test them until they break.
By literally pushing materials to the breaking point, researchers gain insight on how these products will perform in real buildings, under high winds or during earthquakes. These particular panels, comprised of cross-laminated timber with a layer of concrete, were the strongest panels ever tested in this lab. They were designed for a facility in Ontario.
It's a new emerging market, and we figure out what amazing things you can actually do with woods and how far you can take it. So there's room for everything.